Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic Introduction to waveguides. Lecture level outcome. After completion of this lecture, the student will be able to apply the concept of waveguides to solve gate problems. Introduction to waveguides. Waveguide is a hollow conducting tube to guide electromagnetic waves at high frequencies. It is made up of wood conductors like brass, copper, silver, aluminum, or any metal that has low bulk resistivity. It is a rectangular waveguide made with good conductor, means the conductivity of the walls is equal to infinity. It is a hollow conducting tube. The space inside the waveguide is filled with a source free lossless dielectric material. The conductivity is zero inside the waveguide. You can refer to the direction of wave propagation in rectangular waveguide and circular waveguide. The wave propagation inside the waveguide depends on the concept of total internal reflection. The waveguide acts as high pass filter, means it is used to guide high frequency signals. Transmission lines are used to guide electromagnetic waves at low frequencies. At frequencies higher than 3 GHz, the transmission of electromagnetic energy along the transmission lines and cables become difficult. An electromagnetic energy to be carried by a waveguide is injected into one end of the waveguide. The applied electric and magnetic fields associated with the electromagnetic wave uh, bounces back and forth inside the waveguide as it progresses down the waveguide. The more common waveguides are rectangular waveguide, parallel plane waveguide, and circular waveguide. In a rectangular waveguide, the length along x-axis is denoted by A, the length along y-axis is denoted by B, and AB values are in such a way that always A greater than B, and the wave propagation will be shown like this. In parallel plane waveguide, the electromagnetic wave will be guided between the two parallel planes separated by a distance A. In circular waveguide, the cylinder has the radius R and D is the length of the cylinder. Flux lines inside the waveguide. In a rectangular waveguide, it is the direction of propagation. You can refer to the flux lines in TE mode and TM mode. Here, red lines are magnetic field lines, blue lines are electric field lines. Waveguide acts as high pass filter. Let us consider the signal frequency of electromagnetic wave is F, and the cutoff frequency of the waveguide is Fc. It is the diagram which depicts the high pass filter characteristics. F is the signal frequency, Fc is the cutoff frequency of the waveguide. When the condition F greater than Fc, the propagation of electromagnetic wave takes place inside the waveguide, and for F less than Fc, there is no propagation of electromagnetic wave inside the waveguide as it acts as a high pass filter. For F greater than Fc, for F less than Fc, there is no propagation. The propagation constant gamma is equal to alpha plus j beta, and for F equal to Fc, the propagation just starts, gamma equal to 0, and for F greater than Fc, the propagation of electromagnetic wave takes place and gamma is equal to j beta. The cutoff frequency is the operating frequency below which attenuation occurs and above which propagation takes place. Uh, it is the cutoff frequency. The signal frequency above the cutoff frequency, the propagation takes place, and in this region, the propagation constant gamma is equal to j beta. And if the cutoff frequency is greater than the signal frequency, this is a region where the propagation constant gamma is equal to only alpha. The reason is the electromagnetic wave will be attenuated by the property of the waveguide. Wave path at various frequencies. You can refer to the wave propagation inside the waveguide based on the concept of total internal reflection. The signal frequency is high, medium, and low. You can refer to the path length inside the waveguide. And this diagram depicts F equal to Fc. When the signal frequency is equal to the cutoff frequency of the waveguide, there is no propagation inside the waveguide. Modes in waveguides. The field configuration within the waveguide is referred to as mode, and it is divided into 4 sets. TM mode, transverse magnetic mode; TE mode, transverse electric mode; TEM mode, transverse electric and magnetic mode; HE mode, it is also called hybrid mode. In TM mode, Hz is equal to 0. In TE mode, Ez is equal to 0. In TEM mode, Ez equal to 0 and Hz is equal to 0. In hybrid mode, Z is not equal to 0 and Hz is not equal to 0. Once refer to the summary. Thank you. We will meet with the next lecture.